Welcome to this tutorial, guys. Basically, we are going to go over past paper type questions from various past papers. We're going to go from radians to degrees, degrees to radians, cost diagram questions, and some proofs, some really intense proofs. I'm going to apologize in advance. This is going to be a long video, but hopefully you guys find it useful. Okay, so the first question says we need to convert from radians to degrees. So how do we do this? So looking at the first one, we have 3 pi over 2 radians, and we want to go to degrees, so we have 180 degrees at the top over pi, and the answer is 270 degrees. Okay, like I said, these are about 2 marks each if they come up in a test. Next question, let's do 2 pi over 3, and we have radians. We want to get degrees, so degrees come on top, over pi, and the answer is 120 degrees. Okay, 0.5 radians, and again we want to get to degrees, so we have degrees at the top and radians at the bottom, and we get 28.65 degrees. Okay, before I get too far, again, please just do these questions, pause the video, do the questions, and then look at the answers. Okay, converting from degrees to radians. Okay, so in this case we have 290 degrees, and we want to get to radians, so we have the radians at the top over 180 degrees, which gives us 29 over 18 pi. Okay, 60 degrees times we want to get to radians, so we want 180 degrees at the bottom, and we have pi over 3 radians. Okay, so radians are essentially unitless, but you can put radians in, and 2 degrees times pi radians over 180 degrees equals pi over 90 radians. Okay, so again, these are about 2 marks each if they come up. Okay, next we have a nice cast diagram. So let's look at the first question. Okay, so it says let sec theta equal minus 13 over 12 and sine theta is less than 0. So the first thing to always do is draw the diagram, and it looks like that's what they've asked us first anyway. Okay, so we need to try and let's draw it on the side and small first. Okay, so first we need to determine where we are on the cast diagram. Okay, so remember CAST, C stands for cos, all, sine, and tan, and this tells us where the functions are positive. So we have sec. So that's not really on here, so let's rather convert this. So what I like to do is I like to make this 1 over cos theta is equal to minus 13 over 12. This leads to cos theta equals minus 12 over 13. Okay, a quick check is to always know that this is x over r, and your r must always be greater than x because your radius is always your greatest value. Okay, so now we know that we have a negative cos. Okay, so we can't be in this section. Okay, and we also know that we can't be in the all section because of this restriction. So we can't be here, and we also know that we can't be in the sine area. So the sine is also out of bound. So we have to be in the tan area. So let's draw it nicely. So we're essentially here. Now we have to determine, okay, so we know our r, again, r is always greater than 0, so r has to be 13, and so our x value has to be minus 12. Using Pythagoras, we can get that the y value is equal to 5, but remember, x is defined positive this way, y is defined positive upwards, so y must also be negative 5. And again, a quick check here would be that tan theta is equal to opposite minus 5 over minus 12, which is 5 over 12, which is positive. So we are definitely there. So we've done question A. Again, drawing the diagram is probably the most important part, and it's worth 3 marks normally. But if you get the diagram wrong, then you get all of these wrong. So make sure you spend some time making sure that your diagram is correct. So part B says we have to get cos theta. So cos theta is essentially what we worked out here. but let's work it off on the diagram. From the diagram, cos theta is x over r, x is minus 12 over r is 13. So that is also worth 2 marks. Next, we need cot theta, or cot theta, or I think, cot theta, which is going to be, okay, so the way I do this is tan theta equals y over x, so x over y. So cot theta would be x over y, if you're not familiar. Okay, so looking at the question, we have x is minus 12 over y is minus 5, so we have 12 over 5, and this is indeed the inverse of our tan. So those two relate correctly as well. The next question is question D, which is cosec theta. Okay, so because I've got limited brain capacity, I don't know if it's y over r over y, so what I'd rather do is 1 over sine theta, which is 1 over y over r, so cosec theta equals r over y. Okay, so if we have r, we know r is 13 from our diagram, and y is minus 5. So that is the final answer. Okay, so the next question, we have tan 30 degrees is equal to q, and we've been given no other information. Again, we need to draw the diagram. Something like this is probably going to end up being worth, let's see, let's switch this to black. A question like this would probably be worth 4, 2, 2, 2, 2. So there's your mark allocations. Okay, so first we need to determine where we are on the diagram. We've been given absolutely no information besides the fact that tan is positive, so we're essentially here, or we are here. Okay, but we also know that on the cos diagram we measure anti-clockwise from the positive x-axis, so we know that we are 30 degrees, so we're somewhere here. Okay, so let's draw a nice diagram for it. So question A, we have 30 degrees. It's more 45, but whatever, let's label it 30 degrees. Great stuff. And we know that it is Q. So what is the generic tan theta equals let's change that. Tan theta equals y over x. Okay, so we know with that this is Q over 1. So we can put that into our diagram. So our y value is Q and our x value is 1. Again, using Pythagoras, we can get that the radius is equal to 1 squared, which is just 1 plus Q squared. Okay, so now that we've got a very nice diagram drawn, we can go on to the second question. Okay, so I'm going to give myself a lot of space. Okay, so let's go on to the next question. So question B, we need cot 30. Okay, so from the question we could actually work this out, because cot 30 is 1 over tan 30, which is 1 over q, because tan 30 was q. But if we look at our diagram, let's just make sure cot 30 would be x over y, which is x, which is 1 over y, which is q. So both of these ways are correct. Okay, then we have what is it, sec 150. Okay, so one way we could do this is convert it if you wanted to. So let's convert it to 1 over cos of 150, and this is equal to 1 over cos. So we want this value to become 30 because we're working with 30 in the triangle. So to get 30, we can go 180 degrees minus 150 degrees, which gives us 30. But remember that on the cos graph, this gives us minus 1 over cos 30, just from one of our rules. So equals minus 1 over, and what is, let's see, cos of 30 is going to be 1 over x over r, which is 1 over 1 plus q squared. So our answer becomes minus square root of it becomes minus 1 over square root of 1 plus q squared. Okay. No, sorry, that's not right either. Let's see. Rather, if we multiply it, we get minus square root of 1 plus q squared. There we go. That is the right answer. Okay, so just make sure you do that correctly. So we're multiplying by square root of 1 plus q squared over square root of 1 plus q squared. To get rid of this denominator, this cancels, become 1, and then we just have the top. Okay, cool stuff. The next question we have is cosec 120, which we can go cosec 180 degrees minus 120 degrees gives us cosec 60 degrees. Okay, this doesn't really give us what we want. We want a 30, so what we're going to do is take cosec 90 degrees minus 60 degrees, which gives us sec of 30 degrees. Okay, if you're not comfortable doing it that way, you can write this as 1 over sine 120 and follow a similar approach that we did there. But sec 30 is going to be exactly 1 over cos 30, which is actually what we had before without the negative sign, which is 1 plus q squared. Okay. Yeah, so that's the question we have for that. So this is probably one of the harder questions you guys will ever get. Okay, but yeah. Okay, then I just wanted to do a very quick question that I had made up, which was let sine theta equal y over r. Okay, and additionally x denotes the x value or x length. Okay, and we have been given that x is between minus infinity and 0. Okay, so let's just draw the diagram. Okay, so that's all I want us to do, just to get the diagram correct. Okay, so we know that CAST, so we know that sine is positive, so the diagram can be basically between these two quadrants. So the question is, where is it? But we've also been given some vital information that x must, essentially this is saying that x is less than 0. So x has to be negative. If we draw the diagram here, x is positive. So we can't have that. So the correct place to draw the diagram would be here. Okay, and your values, okay, let's just draw it nicely rather. So what you have is r, y, and this x equals square root of, or negative x equals negative square root of r squared minus y squared. Okay, again, there'll probably be follow-up questions, but I wanted us to just be able to know where to draw these diagrams. Okay, so with cast diagrams, the most important thing is to be able to draw the diagram. After that, everything else is basically quite simple. Okay, so now let's get into some proofs. Okay, so these proofs are really challenging. Yeah, so they actually take quite a bit of work, but if you can do these, you should be able to do basically any proof. So like per usual, we're going to work with our left-hand side and our right-hand side. Okay, so let's start with our left-hand side is equal to sec alpha minus cos alpha squared. Okay, so I'm going to start by squaring that out. So we have sec squared alpha minus 2 sec alpha cos alpha plus cos squared alpha. Okay, and this gives us sec squared alpha 1. Okay, so these two cancel each other out, but if you can't see that, this is what happens. Plus cos squared alpha, and these cancel, giving us sec, okay, I'm going to write sec squared as 1 over cos squared alpha minus 2 plus cos squared alpha. Okay, then I'm going to get a LCD of cos squared alpha, and I'm going to have 1 minus 2 cos squared alpha plus cos to the 4 alpha. Okay, and if we look at this, we have to the power of 4, and we've got a perfect fourth. So what I'm going to do is I'm going to make this 1 minus cos squared alpha squared, or 1 minus cos squared alpha, 1 minus cos squared alpha over cos squared alpha. And what we know about 1 minus cos squared alpha, this identity is exactly equal to sine squared alpha. And the reason is because sine squared alpha plus cos squared alpha equals 1. So 1 minus cos squared alpha equals sine squared alpha. So what we have is sine squared alpha times sine squared alpha. So I'm just going to put it as squared over cos squared alpha, which is equal to sine to the 4 alpha over cos squared alpha. Okay, that's as far as I can go with the left hand side. So let's start with the right hand side. So on the right hand side we have 1 over cot squared alpha minus sine squared alpha. So 1 over cot is exactly tan squared alpha minus sine squared alpha. So I'm going to write this as sine squared alpha over cos squared alpha minus sine squared alpha. Okay, then what I'm going to do is I'm going to get a LCD of cos squared alpha. So at this point, we can see we've got the same denominator as our final left-hand side, so we know we're on the right track. So let's see what happens. So we have sine squared alpha minus sine squared alpha cos squared alpha. Okay, that is horrendous. So I'm going to rewrite that as, let's see, cos squared alpha sine squared alpha minus sine squared alpha cos squared alpha. I'm going to pull out these two sine squared alphas, which gives me sine squared alpha 1 minus cos squared alpha all over cos squared alpha. And again, from the same trig identity, we get that this is sine squared alpha over cos squared alpha, which is sine to the 4 alpha over cos squared alpha. Okay, and if you look at these two, great stuff, our left hand side equals our right hand side. So the problem is essentially done there. Okay, cool. So like I said, a bit tricky, but manageable if we know our identities and whatnot. Okay, so looking at the next question. Okay, so with these kinds of questions, if there is no apparent reason to multiply this in, if it isn't beneficial to us to multiply it in, then let's just keep it on the outside for as long as possible. So what I mean by if it's not beneficial, let's say the question was rather tan x over sine x plus cos x times 1 over tan x. Okay, it would make sense for us to multiply this in because these two cancel. But in the question we have right now, it's not very beneficial. Nothing really good happens by us multiplying it in. It makes it a bit more confusing. So let's keep it on the outside. So let's start by writing that on the outside, our left hand side looks something like this: 1 over tan x. And so cosec x is 1 over sin x, plus cot x is cos x over sin x. Okay, and that's all over tan x, which is sin x over cos x, plus sin x. Okay, again, we then leave the tan x on the outside, and let's get a lowest common, let's get an LCD at the top, which is sin x, and we have 1 plus cos x, all over LCD here we have sin x over cos x plus sin x cos x. Okay, I'm going to pull out these sin x's, or let's rather flip them. So let's flip this, so we have 1 over tan x times 1 plus cos x over sin x times, flipping this we get cos x over sin x plus, okay, so sin x cos x. Okay, so what to do now? I am going to pull out a sin x from there. So what we're left with is cos x over sin x times 1 plus cos x. Okay, and these two cancel very nicely. Cos x over sin x gives us, so cos over sin gives us cot x. 1 over sin, this becomes 1 over sin, gives us cosec x, and 1 over tan gives us cot x. So we're left with cot squared x cosec x, and that is exactly our right hand side, and our right hand side is equal to cot squared, it's equal to cot squared x cosec x. So we can say that our left hand side is equal to our right hand side. Okay, so again, a little bit of work, kind of hard, but manageable. Okay, so the next question, before I do the next question, let me do the last question, because it's a bit trickier, or it's something where you need to see something very specific. Okay, so in this question, let's work with the left hand side. Left hand side is equal to sec x minus cot x. I am going to, okay, let me just write it as cot x for now. Okay, now let's get this as 1 over cos x minus sin x, not over 1 over cot, that's essentially equal to tan x, so it would be sin x over cos x. Okay, great stuff. So now we're left with 1 minus sin x over cos x. Okay, right, so I'm happy with the left hand side. There's nothing more we can do. So let's look at the right hand side. The right hand side equals square root of 1 minus sin x over 1 plus sin x. Okay, can anyone think of anything to do? No, it's difficult, so let's think about what we have here. Okay, so I can see a 1 minus sin x and a 1 minus sin x, so we've got the top part. So we need to figure out how we can get this bottom part. So let's think about this. So we also have been given a hint by the square root, because we know that, let's do it in orange, cos squared x is equal to 1 minus sin squared x, right? So let's do something very unconventional. Let's square this side, and then we square root it. Okay, squaring something and then square rooting it does absolutely nothing, and that's why we're allowed to do it. So let's square the entire thing and then square root it. For example, let's say we have 4. This is equal to 4 squared square rooted. Okay, because these two cancel, so we just left with 4. But for this question, it becomes quite beneficial. So what we have is 1 minus sine x squared over cos squared x, which is equal to square root of 1 minus sine x squared over 1 minus sine squared x, which is equal to square root of 1 minus sine x squared over, using difference of two squares, we get 1 minus sine x times 1 plus sine x. Okay, then 1 minus sine x cancels with the square, so we're left with a square root of 1 minus sine x over 1 plus sine x. And this is our left-hand side, and that is exactly equal to our right-hand side. So we can say that the left-hand side is equal to our right-hand side. Okay, so again, you just needed to see the quote-unquote hint, which was that we need to square something, and that's why we get the square root. Okay, so looking at the last question. Good. Let's give ourselves some space because this is quite an interesting question. Okay, again, sec is 1 over cos, right? So multiplying it in gets rid of that cos, but it adds a cos squared at the bottom here. So I am just going to leave the cos as it is for now. I mean the sec. So the left-hand side is equal to sec x cos x over cosec squared x is 1 over sine squared x minus cot squared is cos squared x over sine squared x minus sine x, and we have a minus tan x as well. Okay, so quite an interesting sum we're getting here. So we have sec x again, and we have cos x over, and what we know now is that the lower LCD, the LCD at the bottom here, is sine squared x. So we have this over 1 minus cos squared x minus sine cubed x. Okay, and then we have a minus tan x as well. Cool stuff. So again, we have sine x. Okay, so let's get this cos x as it is there. Let's now figure out what we're going to do here. Okay, so 1 minus cos squared x by our formula is equal to sine squared x minus sine cubed x, and this sine squared x can go to the top now, which is sine squared x minus tan x. Okay, so now we're left with sec x times, okay, let's have cos x, sine squared x rather, and we're pulling out a sine squared x, so we have 1 minus sine x minus tan x. Okay, sine squared x is cancelled, great. So we're left with sec x times, let's see what we have here, cos x over 1 minus sine x minus sine x over cos x. Okay, and we need more space. Good stuff. So, and again, once again, we're left with sec x times, our LCD is now 1 minus sine x times cos x all over, multiply Adding that up, we get cos squared x minus sine x, and just for that's what we're getting, so I'm just going to multiply that straight. Sine x minus gives me a plus, so minus times a minus gives me a plus, sine squared x. So we're left with sec x times cos squared plus sine squared gives me 1 minus sine x over 1 minus sine x times cos x, which these two things cancel, gives me sec x times 1 over cos x, which is equal to sec x, which is equal to sec squared x. So our left hand side is equal to sec squared x. And if we look at our right hand side, it's also equal to sec squared x. So our left hand side is equal to our right hand side. Okay, so like I said, some really interesting, somewhat difficult questions where you need to do a lot of thinking. But yeah, so essentially, don't be scared to try weird things like squaring something and square rooting it. A very important NB is to know this formula: sine squared x plus cos squared x equals 1. That pretty much always comes around in most questions, and look for fake hints that you're given. So I just added this in the end because I saw it and it looked quite interesting. So we've been given this and we just need to prove it. Okay, so let's start with the left hand side. As per usual, left hand side, that's quite thick, so let's rather change it. Okay, left hand side is equal to 4 over cos x squared is 1 over sine squared x plus sec squared is 1 over cos squared x. So we have 4 over, getting an LCD, we have sine squared x cos squared x over sine squared x plus cos squared x. So we have 4 over 1 over sine squared x plus cos squared x equals 1 over sine squared x cos squared x. So this is equal to 4 sine squared x cos squared x. Okay, that's as far as I can go with the left hand side, so let's work with the right hand side. So our right hand side, we have sine squared 2x. Okay, so this can be written as sine 2x squared, which is equal to, using our hint, 2 sine x cos x, sine x cos x squared, which obviously gives us 4 sine squared x cos squared x. And so we can see our left hand side is equal to our right hand side. I had another problem here if you guys want to attempt, but I will not be going through the answer because it is quite easy. Actually, I don't even have the question. Oh, no, I do. So the last question that you guys can attempt if you want, it's much easier than the others, but it's also something worth trying, is sec x cosec x minus cot x equals tan x. Okay, so the process is to convert everything to sines, cos, and tan, and note that 1 minus cos squared x equals sine squared x, and knowing that, you guys should be able to get it. So yeah, okay, thanks for watching. If you're able to do everything in this tutorial, then you should be able to do your test, and I think you guys will be fine. Again, these these trig identities. Proving them were quite tricky. There's some that are quite difficult to see. Always use your hints that you're given, even if they're vague. And yeah, thanks for watching, and good luck, guys.